Hey, CHEM 2P21 exercise people. This is a short video about Reaxys. Most, if none of you, have searched Reaxys before. So we'll go over about why we have it, how to use it, just to get a better sense of how chemistry people think with these sorts of databases. Again, we go to our Brock homepage and click on the research guides. You can get to it different ways, but this is the best way. It's in several databases. It's mainly restricted to chemistry. And there's the Chem 2P1 tab page on this guide, which all those sorts of things. And again, this video is archived here if you want to look at it again. The first question, which SciFinder kind of answers for you, but Reaxys does as well. You know your compound. We're using this example of amoxicillin. The formula, the CS registry number is in both places, as we'll see. IUPAC name, many different names. A Reaxys ID number is here as well, though that's in different sources. If you haven't captured an image of the structure and sourced it, you can do this here or in other places as well. So Reaxys ID numbers can be found using Reaxys. The first Reaxys question is question number 6. It says do a quick search, and we'll show you what that means. So you can click on Reaxys, different ways to search the literature. If you know what you're looking and you want to look for something quickly, and we'll search other ways you can do it. And it's the default as we search the database in a second. You need to find a number of substances for your compound, a number of documents, and a number of commercial substances related to this particular compound. Then we want to do substances view results, and I'll show you. And then we look at specific, not only the class of compounds, but this particular structure. We want to know how many preparations, reactions, and documents are related to this particular compound, just not all that family related to amoxicillin or your particular compound. This will become self-evident in a minute. The other question is Reaxys is to go to query builder. So it's kind of like, because synthetic organic chemists want to know how this works. They're preparing something in a reaction sequence, looking at yield and tools and how many steps. And so where this falls. And so you can build up your chemical structure, not run it as once, but it gives you answers at different steps of what your best choices are, what's available and what people have done. And again, in chemistry, you don't want to repeat something what somebody else has done because it's very expensive and time consuming and kind of embarrassing. But you want to know what other people have done to inform you of what can or can't be done, or what's new or emergent in this particular database in chemistry and in interdisciplinary resources as well. So it says do a quick search, query builder search. We're going to open and we're going to look at search for reactions to run. We'll click on a number of filters. We're looking for patents as document types, and we want to pick one. Then we want to go to the ISPASnet database, which I kind of alluded to in SciFinder. And in Reaxys, it's linked quite well. And then you have to cite a patent. So there's an example of cite a patent. Not only do you cite it, but you highlight it and link it with a URL. So you provide the hyperlink to that particular topic. And then in 1 or 2 sentences, when you look at the patent, you have to identify what's novel or unique or new about this patent, because it was patentable. So the people who look at these thousands of documents every day said, this is new, it hasn't been done before, and yes, it's an idea in chemistry, a solution or reaction or sequencing that we will give you a patent to protect your intellectual property rights for it. And so in 2 sentences, that's what I wrote for this, but you will write something different, but 1 or 2 sentences, what is new or novel about this particular tool? So that's how we're going to use this particular document. So let's jump into lots of things to look at here. Let's jump into, bear with me, our homepage. Again, looking for things here, go to research guides, chemistry, Chem 2P21 guide, and the video for Reaxys is here, as well as other tools that you could use as well. We know it's for properties, and it's for drugs and chemicals, but we're looking for articles on this particular topic. And though we use other databases to search other things, including SciFinder, we want to search Reaxys. And here there's a video suite of tutorials to know how to do reaction searching, patent searching, structure searching, lots of things that give you a good introduction and show you how to do it hands-on as well. You can go into Reaxys. Now, you don't have to register, and it doesn't ask you for a password. It authenticates you're part of the Brock University family, like most things do in our library, and it knows who I am, so I'm on this computer and jumps me right in. No, I don't want this. So here's the front end. Just as SciFinder had a search by substance or by words, here it just gives you one search strategy. So you can put in words, your compound, see what happens. And there's the quick search that we're going to use, which is the default. A synthesis planner is where a team or a grouping of people, and this happens quite a bit, tracks things and then asks the database every time the database is updated, let's say once a week, run this search alert or profile based on a reaction or a series of compounds or a research team, and then email me the results in one email. And if there's 10 or 20 links to articles, sign in and get them. It keeps me aware. So every week I go over these to see if something's happening. It doesn't stop me from going in and looking at things myself like we're doing now. But the synthesis planner helps keep things along and documents how everybody's doing. So 10 or 20 people can belong to a synthesis planner team. It's kind of like a shared document and resource. It's very important to synthetic organic chemists. So here it asks you for that question. It says, find your compound. So I know I'm looking for amoxicillin. So kind of gives you a hint. I want to click on find. If it's there, I know it's there. And this is the first question. So it says, how many substances, how many documents, how many commercial sources. Now you can go down any one of these links. And then the nice thing about Reaxys, where SciFinder said, do a chemical structure search, do a reference search, do reaction search. Here you can jump from one. It's a pretty more robust. The neat thing about Reaxys is it includes the same sorts of documents. It takes documents from Medline, whereas SciFinder takes the whole Medline database. It takes articles from other areas. Again, it has more properties, more reactions, more compounds. It's not as fast or as emergent as SciFinder, but it's used to figure things out, like synthesis planning and query building. So it may answer the same question that SciFinder does, or Web of Science, or Google Scholar, or Omni, but it does it in different ways, but you need to speak the language of the database. So the first question asks you that. The next question asks you is, for substances, view the results. So let's just go down that path. And what it does is it gives you 500 substances. So there's lots here. If you go down, there are anhydrides, there's salts, there's stereoisomers. And so there's not too many. Usually the most powerful one, the most appropriate one with this structure alone is here. And then it asks you here, I'll move this over to grab this number. There's 23 preparations for this compound alone, not this class of substances. How many reactions and how many documents, which is quite a few. And if you look at it, if you remember, it's more than SciFinder did. Why? You just kind of have to get into the head of the database, but sometimes it gives you more results and better results than SciFinder. But again, it searches almost the identical database as well. So let's go back. And so those are the three numbers. So that answers the first question of two sets of three numbers. You can actually go down to these and look at the documents of the reaction. And also you can, if you want, you can take this structure, find preparations and synthesize it. And what it does is it puts it in here, and then you can take this one document here and then add that, copy to structure query, and here it is here, so you can click on here. And the SciFinder can do it. You can block out here, add here, substitute. It uses different tools the same sort of way and different platforms to visualize, but then you could take this document and search this structure and allow here, here, that, there, exact, and transfer to query. So it is pretty flexible like SciFinder is. It works and it has sometimes more options, but again, it speaks to the language of the database. But the end of every search is a patent or an article, usually other formats as well, but it's usually a patent or an article that you can cite because it's built on a body of knowledge like all sciences do. How did this add to the body of knowledge? Lots of information as well. So that's question number 6. So you can always go back. You can always click on a new search. You can do, it remembers where you are. You can say, I don't want to do that as well. So that's where we are back again. The next question asks is use the query builder just to give you a different way of tackling this and think how chemists do, and medical sciences as well. So it asks you to here, again, you can at any time jump off and try different things, but we want to search the compound and see how Reaxys asks for a CAS registry number. That's how important these are, because it's a universal, excellent current tool, put in the dashes as well, that works, even though they're stealing or borrowing tools from another database. So here it is. So you go looking at this. And so what it does is it allows you to search and use different functions. So you're building a query. And again, you can save this as an alert and run it and tell the database to tell you what you find every week to see if there's anything new that you may want to find. So it looks at These are, listen, you can look at spectral properties, different types. You can look at pharmaceutical. We're looking at reactions, and so it asks you to look at product reactions. Okay, we're looking at that. So it adds that. So we're doing this product reactions using all the functionality of the database as well. So we're going to search for documents. So we're going to search for reactions. And so you can go different ways just depending on the questions that you ask as well. Gives you the filters on the left this side, and then these are sorted. You can rank them and sort them by any means, by reaction, yield, relevancy, date, and go through these and say, oh, this looks good, or that looks interesting, or oh, then you can save these and put them into your history or synthesis planner, meaning I want to stick this in for everyone to look at. So what you need to do is you need the filters on the left-hand side. So it says, let's search for document types, and here, let's give no entry, but sometimes it says patent or article, and we want to limit to these sorts of things. I wish it was more exact, but we're going to search for these and limit to them. And we want to find a patent. Now, you think all these would be patent. If it says patent, it is. But I know there's articles in here. And again, you could sort these by currency, date, or relevancy. And you just go through these. Is this answering? And then it's the clickable links where you can add these to different. You can then look at the full record and the details in the abstract to know what they're talking about. So you need to find a patent that looks interesting. Preparation. Synthesis for our particular compound. This looks interesting. Let's grab this one. And it works full text. The neat thing about this database is that if you look over here, it says SPOSNet is the database we're looking at. So it actually takes you to the record in another database. It's linked quite well, and it works almost all the time, where in SciFinder it works most of the time. So here's a patent, an idea that was patented, meaning it was proven to be novel or new or an idea. It looks like it's Chinese, whatever. You can actually get the original document here, which is just amazing. And here it's how many pages? It's 120 pages or so. And then here's the table of contents for that. The claims are what you want to know, because the claims are what you have to prove to the people you submitted this to, that this is novel or new and worthy. It hasn't been duplicated, and it's worthy, and it's a piece of scientific exploration and work that's patented. Well, the neat thing about this is you have to look at the claims, and the database here allows you to transliterate the patent from one language to another, and then there's about 15 different languages that does this well. Now, I can't tell, I don't speak Chinese or read it, but it tells you these are the claims, and how many are there? There's what, 3, 6, 7 families of them. So these are the claims that they've made, that the patenting agency, SPOSNet, and it's the World Patent Organization, said, well, the Chinese patent agency says this is worthy. So you need to kind of crib this in 1 or 2 sentences and see what was the novel idea. Now, if you're not a chemistry major, you may go, oh, what am I doing? Well, but you have to synthesize this and look at this. Look at the abstract that's in Reaxys. You can look at the claims. The last thing you need to do is you need to go back and you need to click on here. Patent translation or the original record, and claim the URL and cut and paste this. And when you cite it in your patent, let me do this here. When you do this in your patent document, here's the bibliographic data here. You know the title, you know the inventors, you know the patent number, and sometimes it's hard to know what number to use. So here's the patent number they use. I include the A because it's an abstract, and you need to translate this. But yet, see, here's that abstract. So what was novel or idea? The words cheap or new or number of steps. Usually we've used fewer steps. We've used different types of reagents. We've a novel way of doing this chemistry. And the patents are done for lots of scientific communities. It's done in chemistry because there's a lot of money to be made for this. And originality accounts for everything, not only in the academic world, but in the corporate world as well. So there you go. Let me just go back to where we were. So here's the home page for chemistry. Don't rule out chemistry 2P2 101 sites for the examples of how to script from an article and a patent that's here. Scholarly communications here, the forums and the other tools that are here as well. So good luck on this exercise. Hopefully Reaxys will look interesting to you. You'll be able to navigate it appropriately to answer the questions for the exercise. Then get into a SPOSNet, and then declaim what's new or a novel idea, and use your writing skills in 1 or 2 sentences to summarize those particular thoughts. So good luck with this exercise.